Chapter 6 is about gases. There's a quote from James Clerk Maxwell. So many of the properties of matter, especially when in the gaseous form, can be deduced from the hypothesis that their minute parts are in rapid motion, the velocity increasing with the temperature, that the precise nature of this motion becomes a subject of rational curiosity. He's talking about what the heck are gas particles doing? So we'll learn about that. Have you ever thought about breathing? How exactly does that work? Boyle's law. Yeah, actually it is. You're not supposed to know that. So we breathe in, we breathe out, right? 8,500 liters of air pass through your lungs in a day. That's about 25 pounds of air. That's a lot of air. And breathing is possible because our bodies create pressure differences. When we inhale, our lungs expand, and when the volume of our lungs increases, it causes a decrease in the pressure of the air in our lungs. The exterior pressure is constant, and so that causes air to flow into our lungs. When we breathe out, we push up with our diaphragms, compressing our lungs, making the volume smaller, increases the pressure, and that pushes the air out of our lungs. Repeat over and over and over again. So breathing is possible because of pressure differences. Well, what is pressure? Pressure is a force exerted per unit area. So the gas molecules, as they're moving about, doing whatever it is that they do, they run into things. They hit the sides of your lungs, they hit the chalkboard, they hit the walls of your tire. And when they hit something, they exert a force. Now that force is really, really tiny, right? But there's a mind-boggling number of gas molecules, say in your car tire, that are hitting the surface, and they're hitting it very frequently. And so all of those little tiny forces add up. It's like a raindrop. Is a raindrop going to, flood your house? No, it's too tiny. But what if you had a gazillion raindrops? Causes a flood, right? All of those little tiny things add up. And so that's what happens with gases. So pressure is a force exerted over an area. Now I'll just acknowledge the title of this section is Supersonic Skydiving and the Risk of Decompression. I'm not going to talk about that. This is from the older version of the textbook, and I really like it, and so I'm just sticking with that. So gas pressure depends on several different factors. It depends on the number of gas particles in a given volume. We don't usually call it a concentration, but that's what it is. We just got done talking about molarity as the moles of substance per liter of solution. Well, the number of gas particles, the moles of gas in a volume, in a liter, would be a concentration, right? The volume of the container is going to affect the pressure, and the average speed of the gas particles will also affect the pressure. Kind of got ahead of myself. You inhale, your volume of your lungs increases, so the pressure decreases. The gas concentration decreases. Constant external air pressure causes air to flow into your lungs.